So I'm also going to record this. I know it's great. I've got some teacher friends who are MacBook users, so they don't have access to Streamlabs, which kind of sucks for them. Um, but there is OBS. I know if you're a Mac person, I haven't tried it. I've only really tried Streamlabs. Use Mixer. Oh, for streaming. I've never used Mixer. Is it any good? Mixer. The next generation. Ooh. Why is it better than Twitch? This looks like a cleaner version of Twitch. I know that you can stream to Mixer through Streamlabs and everything that I have, so um, we'll see. I mean, if this doesn't work, then we'll move. Like, the million emails you've all gotten, this is an experiment for everybody. So I'm going to expect technical glitches. The fact that I can actually see your chats on the side is already a win for me. Because the goal is to try and make things as seamless as possible for all of you. I mean, obviously, face-to-face is better, but this is at least my next best thing. If it works, we'll go with it. If not, we'll try something else. So a couple of things for you. The chat's fine if I start talking and not paying attention to the chat channel. There are a couple of different ways you can get my attention too. So let's see. I'm not sure why this is now. Ugh. Okay, come on. All right, so I can't seem to move my window around up here for some reason. That's pretty cool. And none of the usual commands work for moving it. All right, bear with me 1 minute here. We already have our first technical glitch. And okay, it's a little bit smaller. And go back to extending. All right, this will do. So first things first, if you guys want to get my attention, there's this redeem raise hand command. So if there's a better way to do this, let me know. This seemed to be the easiest thing I could figure out. But you do that, and then a little guy's going to pop up on the screen. So Tails is going to get really excited. I will see that in the stream, and hopefully that will be a good way for me to, come on, to basically, see what's going on. All right. Now, I've got this really bad tiny monitor that I should have gotten a better one here. So yeah, we've got that. And also, if you want, so I also have the Discord channel still. Did this go in the right spot? Okay, good. Got a little ping in there for you guys. If you want to join the voice channel, I am muted myself, but you can actually get on there with the mic and just talk. So I will kind of idle in this channel. Please enable push to talk if you want to do that. So, we don't hear everybody clearing their throat every 5 minutes, just me clearing his throat. But I'll leave that on. The only thing is that if you don't want to be recorded for this, this is going to be uploaded to YouTube for after the class is done. So if you don't want your voice on YouTube, either let me know or, just chat. But other than that, it's pretty much going to be the structure from here on out. Yes, exactly. This is kind of fun seeing your actual thoughts going on here. So other things too, obviously for you guys, there's a couple of things to worry about. So the in-class labs, I mean, I mentioned this in the email, but basically what we're going to do is I will cut the stream, when we start doing the in-class work, and I will move over to the Discord voice channel. And if you guys want to work on, the stuff during the normal class period, you're more than welcome to, ask me questions through the voice channel or through the chat channel. We can use either. But I'd still like to, have you all get practice with some of these tools. So like today, we're going to probably not go the whole time. So we're going to look at some of the other libraries that are out there. And what I would like you all to do when we're done is to be able to implement some kind of a demo project with one of these libraries. So pick your favorite, pick whichever one seems interesting, and you're going to do something with that. Business as usual with uploading it to Moodle. Just kind of show me what you've done. You can go as complicated or as trivial as you want. If one of these libraries is going to help you out with your term project, by all means explore that. But yeah, I suppose I'm only going to be talking about a handful of these libraries too, so if there's another one that you're really excited about and it's not in here, feel free to do that too. Anyway, let's see. So last thing, your project demos, presentations, special topic presentations, that's probably the other concern that you all would have. My current thought is for you to do a YouTube recording or some kind of recording and share it with the class. So your options are to, record you walking through your lecture presentation, put it up on YouTube. You can use Discord's Go Live feature. We could do like a Google Hangouts meet. I could set up a WebEx if that's preferable for you. Basically, just communicate with me before it's your time to go, and we can figure that out. And, if you don't have a webcam or a microphone, that's fine. I mean, you can use your phone to stream to Discord or to any of these streaming platforms. That's definitely possible. But if there is a real issue, I think we can check things out from Oakland too, worst case. But I mean, I would still like you to do your presentation, still like you to walk us through your demos. Whatever's going to work out for you, we'll just figure it out kind of as we go. And I'm not sure if Kyle's online, since he's going first with the demo or the presentation fairly soon. Yeah, basically, whatever you guys want to use, whatever you're comfortable with, I'm fine. You can even use, Twitch or Mixer or whatever you want. But other than that, that's kind of the highlights of what I have to talk about for the basic class things. If anybody has any questions, throw it in the chat or anything like that. I guess other thing too, I took the soundboard off, not because I don't trust you guys not to abuse it, but if random people kind of drop by, I'm sure that's going to eventually happen. I don't need Obi-Wan saying hello there 30 times in a row while you guys are trying to get the course material. But other than that, we can get started here too. Do the same dates apply? So I should probably be reading these questions since I don't have the text going through the screen yet. The same dates still apply unless if you want to change it. So my current thought is to run the class as like we're still all there in person. Now, if that's going to be a problem for anybody, I realize this whole thing's throwing everybody for a loop. Just let me know and we can figure it out. Obviously, working from home, we have a little bit more flexibility with time. Yeah, no, absolutely. If you're ready, I mean, we can do that. So probably what we'll do for the presentations, honestly, is that we will watch it together during class time, would be my guess. And then we can talk about it after you're done. I mean, if you're ready, you can go whenever you want, honestly. So we have a little bit more flexibility. I'm not going to be, I would like to stick to the dates that we've already set and agreed upon, but if there's something that's come up, by all means, we can change it if necessary. But as far as I'm aware, the school dates still apply, like the last week of class is still the actual dates. The final exams are still, that week. So for your term project deadlines, we've got that. And now that you're all at home or in your dorm, it's a good time to work on your term projects if you haven't started yet. Still get to do the angry professor look. All right, so other than that, we can get going. Again, if you all have any questions or if anything pops up in your mind, just please let me know and we can figure it out. So far pleasantly surprised with how well this is at least seeming to go. And this is no longer based on the Angel book. This is various Google things that I've cobbled together for this. Okay, so plan for the class. We talked about WebGL, and I feel like you have enough of a basis where if you want to take that further, you are more than welcome to. Now we're going to go into some of the other libraries that are out there. And then after that, we're going to dip into Unity next time. And we'll start doing labs as well. So everything that you've done so far in WebGL, I have no memory of why I made this first slide of tape, other than you all should know what a tape looks like. Everything you've done so far has been by hand. You have used the shader language, you've used the JavaScript backend, whether you went TypeScript or not. If we did a little bit more strict usage, it was very painful. It was very strenuous in a way. There was lots of points of failure for this. So obviously, when we have something like that, people will create libraries and wrappers around it to make your life and their life a lot easier, right? So instead of having to define every single vertex for a cube, some of these libraries will just go ahead and define, well, here's a cube. And then the function call that they make for when you instantiate this cube, it's going to go through and place all the vertices. It's going to set up the shaders and do all of that kind of thing. But instead of having a massive JavaScript file, you're just going to have 1 to 5 lines of JavaScript code, which just instantiates this thing. And then it's treated like an object. You can apply materials and textures and lighting, and this is all going to kind of seamlessly work nicely, which is great. Honestly, it makes your life a lot easier, and it leads to more rapid development, honestly. But I mean, at least for me, I'm very happy that you all got the basis in WebGL. There's a lot of debate right now whether people should even be learning WebGL, whether we should just use something like Unity or any of these other libraries. And to me, it's good to know the nuts and bolts of how these languages work. It's kind of like the argument of using C versus Java in a way, right? Because if you take Java, you have no appreciation for memory management. It just automatically happens. Kind of a similar idea here. But for us, it's good to kind of know how all the vertices and shaders work together. So we're going to talk about 3 right now. And I forgot to enable the mouse look, so hopefully you can see my little white mouse, but there should be a little icon around it. I'll have to do that next time. We're going to talk about 3.js in a little bit more detail than the others. So 3 and Babylon, these are 2 WebGL frameworks. They're very, very popular right now if you want to do any of this kind of development. So I'd recommend one of these guys if you're going to be doing, any kind of WebGL outside of class, if you're going to be using it for anything in particular. The other 2 we're going to talk about, we're going to mainly talk about phaser.js. This is a 2D library. It's very well regarded kind of in the game development community more than anything. You can use it for basic websites. It's not strictly WebGL, but it's a very it's a very interesting library. If you have any desire to make a 2D game, there are lots of great tutorials for Phaser. And the other one out there that's also very popular too, we're not going to talk about it today, but I know there's a lot of references to that, is Pixie.js if you want to also do a 2D game or a 2D application. There are a plethora of others out there. There's, I think, Love 2D. If you want to get into some of the physics simulators, there's like Fizzy.js. There's Box2D. So there's a ton of libraries out there. The joke that there's a JavaScript library for everything, this is where we start seeing it, are with these. So again, why do we have them? They're basically abstraction layers. So, I've kind of hit this point home, but handling every single vertex by itself is kind of mind-numbing, and it's very easy to get lost in these giant arrays and numerous buffers, and if you're dealing with multiple textures, it can get very difficult. That being said, if you like WebGL by itself, or straight OpenGL, by all means, go for it. But, more or less, it can be fairly difficult. So we're going to start with 3. I am going to dip over to somebody else's presentation. I will basically give it in a little bit here. So there's this David Lyons intro to Three.js. It's actually fairly interesting. And the reason I'm just going to give it verbatim is that I absolutely love his presentation, which you will see. It's a web-based presentation tool. And if this is something you like, there's this Medium article as well. It's a pretty good intro to Three.js. So in Three, we have very similar concepts of what all of these objects are that we've been using in WebGL by itself. So there's a vector3, which is very similar to our vec3 that we've been using, right? Every time we want to define a 3D vector, we define a vec3. Here, what we define is a 3.vector3, and then here's your x, y, and z, and we don't necessarily have to worry about the homogeneous coordinate here. I should mention a lot of the 4D transforms, while they are available, they're going to be handled automatically for you. So here, for instance, would be a vector that we could define. X, y, and z would be 1. Right? It's also a const, so that means that it's not going to change. So this is a constant vector. All right. So if I needed a vec3, here's how I would do it. Now, let's assume that I also want to create a bounding box. Now, a bounding box is actually quite interesting. So we haven't really talked about this outside of collision detection, and I should probably make sure that I'm not going off camera here. But like if we're going to draw a sphere, or we're going to draw, a triangle or some kind of object, like when we had that clicker where we just draw a random polygon. One thing that you can do is draw a box around it, and that's your collider, right? So if anything interacts with the box, a collision has happened. In Three.js, and honestly other languages too, you can define a bounding box with this box3 function here. But what this does is it creates a box that's world aligned. So basically it's aligned to your XYZ axis. So here in this example, we see the sphere that's been defined. Here we have our frame, our XYZ, and we have our little origin here. This bounding box is axis aligned. So when this box3 has been tied to this object, so the object here is in parentheses, sphere was defined as object, we're going to set a box around this object. So this is that AABB collision detection, or the bounding box method here. Very easy, right? 2 lines of code. We've created an object somewhere else, and now we're just going to draw a box around it. Now the box is invisible to us. Obviously, we don't want to see a wireframe box around it, but it's also going to be very easy to draw that if you want to see it. So very, very straightforward. Again, makes your life a lot easier. All right, just to check, just because it's the first time I'm running the stream's okay. Everything's sounding good. Anybody have a question here? All right, so I'm gonna have to, so there's supposed to be a sound that plays with that, and interestingly, I'm not hearing it. So I have to figure that out. I should also mention, if any of you are Twitch experts and you have any suggestions for how to make this better, feel free to let me know. I am totally open to suggestions. All right. So in Three.js, we have some visual things and some invisible things. So obviously the box collider is one of those invisible things. We can't see it. It's just there to make our life easier for interaction. Not just collision detection. Maybe we're ray casting, which we'll see later. Boxes are helpful for that too. But let's say we want to change something that is visible. So we can change the geometry fairly easily. We can play around with materials very easily. Again, this is shape and appearance. How are the vertices defined? What texture are we slapping onto this thing, right? So think of it like your vertex shader, your fragment shader, in our straight up WebGL. And basically we should be seeing a lot of analogs here, right? So if here, for instance, I'm going to define a cube. So I'm going to create a geometry, and you're going to see this 3 in caps. This will obviously change library to library. Here we've imported the 3.js library. We reference all 3 related objects with capital 3 and then whatever we're going to call. But here we're defining a box geometry of size 20, 20, 20. Right? So it's a cube of basically 20 units. It's going to be aligned at the origin until you go ahead and like translate it somewhere else. So very similar to our WebGL, our straight up WebGL workflow. We're going to define an object and then place it or rotate it or whatever you want to do. Okay, so that would get us a box. All right, so here what we're seeing in the top, there's our box. It has kind of this default color slapped onto it. You can also define a sphere fairly easily, so we don't have to, run our mathematical formula of calculating out the radius and where all the vertices go, and how we connect them all. We're not drawing triangle fans or we're not drawing triangle strips here. We're just saying draw a cube, and 3JS is going to handle all of that low-level shader for us, low-level shader work. So we have our 2 geometries here. Obviously, we're redefining the variable. If we're using straight up JavaScript, it's not going to care. You might get a warning. If you're using something like TypeScript, this would be verboten. But, very, very easy. And we have other geometries too we can talk about. So if you want to use a cylinder or a cone, those are available as primitives for us. All right, so these are some of the basics of 3JS. Now, your first Hello World 3JS application would look something like this, right? So we haven't defined any objects. This would be a blank page. But what we have is our basic HTML page. So again, this is still a web-based thing. We're going to define our website. We're going to put all of our basic tags in there. And then we're going to include the 3JS library. Now, in this example, I would have a folder called JS, and I would have pulled down the 3JS library into that folder. This would be like an index.html that we're looking at, but fairly straightforward. So consider this to be the analog of importing the books libraries, for instance, right? So getting that the matrix libraries and the matrix math in there. And that's kind of a good thing too. If you're going through the internet looking for examples, a lot of them will include matrix math libraries. So you might have to go out and find those. Like I know there's a lot of examples which use a GL matrix library. It's a open source library. I don't remember what the GitHub page is for it, but basically you just pull it down, put it in the same folder, and away you would go. That would give you access to some of the easy transforms. Again, our book takes care of that for us for the WebGL stuff. A lot of basically production applications will use this other one. So here's where we will see if this Twitch chat is good or not. Does anybody can anybody see what the difference to this is from what our normal applications are? So obviously we're not including the books libraries, but there's a very key difference here with what you've all been doing the entire semester to this. I'm curious if anybody can notice what that is. And this is where my joke about me being like a Dora the Explorer episode actually holds. I just sit here and stare at the camera until somebody figures it out. Okay. I'm gonna need like a little treasure map popping up in the corner for Dora to go find. There's no canvas element. Yeah, there's no shaders as well. 3 is going to take care of that for us, but we don't have a canvas. So we're not linking up to a WebGL context, really. So the way 3JS handles it is it just is going to define everything internally in JavaScript. Now what we're going to see in Babylon is that we have the option for WebGL or HTML5 canvas graphics editing. Basically, you're going to get lots of options, but by and large, the 3JS applications are going to go canvas-less, right? So everything's going to be defined in JavaScript. Okay, so this is where I'm going to dip over to these slides, and after that, we're going to go into Babylon. Um, but I honestly, I love this guy's presentation style. So what we can do here, let's make this full screen. Um, so the slides are in GitHub. This person actually gave this talk at a conference several years ago, but a lot of it still holds with Three.js. But basically, he's embedded um, all of his Three.js content right into his slides, like in real time, which is super cool to me. Now, I'm not sure if this particular website is something that he made, but I know there's a lot of various slide technologies out there for doing it straight in the web. All right, so um, I'm gonna skip through a lot of the basics because you already know all this with WebGL, and what it does basically. So he does have some pretty cool examples of what you can do with WebGL. So obviously we've been doing it in terms of, hey, let's draw triangles, rotate things around, let's do some basic animation. And we started getting into importing textures and all that kind of stuff. But you can do some really interesting things with WebGL. And again, if you're going to be doing it by hand, you're going to have a very difficult time getting to this level of fidelity. Right, so here are just some examples of what people have done with WebGL. So we had some maps. There's a Disney animation in there that I saw, but basically it's really, really cool to me. And shouldn't be happening. All right, Three.js, go through this again. Interesting. All right, so that happened. Okay, so this is one of the examples, and I know that I saw, Kyle was working on kind of a snowflake, snowscape type of thing. This is a WebGL particle example. So at one point, one of our assignments in class was that particle generator, right? So let's have all these particles on the screen. This is basically the same thing. So there is a Three.js particle sprites example that's out there on the web. And actually now it's going to interact with my mouse too, which is pretty cool. Kind of just panning and, moving with the camera around. Camera can see. But here we just have particles with texture slapped onto them. Is it dropping frames? It's running at about 34 frames per second for me. I'm not sure what the stream's going to look like. It actually looks maybe slightly chunky. If you want to look at this outside of, if you want to just go to the presentation yourself, that might be a little bit better for dropping frames. I should mention too I did not catch that. Good catch. I've got to run Streamlabs with my integrated chip, so I'm running this on my laptop with it's got an NVIDIA chip and it has an integrated Intel chip. Streamlabs only gives me a black screen if I'm running the NVIDIA chip for this, so I'm going to guess that there's going to be some chunking with like real-time things. I tried streaming Spelunky the other day in a little Binding of Isaac just to see how it would look, and it seemed okay on the stream, but maybe something like this is going to kill my computer. Should actually get maybe a riser going here too so that I can, let's try this. Sorry, 1 second. Let's lift up our PC and we're gonna get a slightly tilted view, and maybe letting the fan breathe is gonna be a good idea too. All right, so snowflakes, pretty cool. This is actually, I should also mention this camera movement we'll talk about fairly soon too. There is a controller for handling camera movement. There's a controller for basically allowing your mouse to interact with where the camera's looking at, and it's literally like 3 lines of code rather than having to handle all the camera translations yourself. Okay, so 3, this is again, it's a JavaScript library for making life a little bit easier. It does render to WebGL in the canvas element if you want. We haven't talked about SVG, but that will also be an HTML element that you can render to. SVG tends to be very popular with like vector-based drawing. So you might see a lot of logos drawn in an SVG element, or you might see vector-based applications. And again, vector drawing is where you define like a point and its magnitude, rather than having a bitmap type image or something like that. So with 3, we have a lot of very powerful utilities. Obviously, cameras and geometry we talked about. 3D model loading is great. Lights and materials and shaders and particles and all of these kinds of utilities are baked into it. And you're going to see the same thing with Babylon too, and some of the other libraries that are out there. I know that I've shown either this or something like this before. I want to say maybe it was the Babylon one that we looked at. But basically, there are a ton of examples and demo code repositories out there for these various libraries. And they all kind of look, like this kind of a thing. So here's what, Crossy Road, I think, written in 3JS. But the cool thing with this, and hopefully this doesn't kill something here. Yeah, so this is I'm pretty sure this is a 3 application. So it looks like we got, it's either Yoshi or a duck, I'm not sure. But again, these libraries make something like that a lot easier. And I'm sure all of you that have done any kind of game development or any kind of difficult project know the value of a library to save you some headache. But the downside to some of these libraries too is that it's obfuscating and it's hiding all of the undersides. So if you have a library that you're using, I'm not saying anything bad about 3 or Babylon or any of the other ones, but if you want something that's a little bit more performant, it's always going to be preferable to handle everything yourself. That being said, there are a ton of optimizations baked into these as well. So it's kind of, do you want to have direct access over an array of millions of particles, or do you want to use the well-optimized particle library, which currently works, but maybe in the future it's going to be less than optimal. So your mileage may vary, obviously, with this, but feel free to use whatever you're comfortable with, honestly. And you're going to see, similar things with Unity. It's going to take all of the headache out, and it's going to make life easier. So here we have a spinning cube, right? So this is a very basic application. There is some kind of boilerplate styling code in here. So change up the body style so that there's no margins, no padding. Basically make it, straight box with kind of nothing padding the screen. Hide any overflow. So basically we're going to hide anything that goes off the screen. And then include our library here. So and that's the other cool thing with this presentation, it's literal like text. So I can select it without clicking and it goes to the next slide. Love it. But here they're including 3.min.js. So this is a minified version of the library. So currently it shouldn't be too much of a problem. Basically, they just have gotten rid of all the white space in the library file. If you open up this particular code, it's going to be like a single sentence, which is just a horrible mess. The idea is to hopefully transmit the JavaScript file a little bit quicker, maybe make it a little bit harder to reverse engineer. But you're going to see this very commonly too. One of the other ways that you can load it in, this is going to hold for any library. Often there will be content delivery networks which will host the latest version or a particular version of the library. So you'd go to something like cdn.cloudflare or GitHub or something where you're going to actually pull the library down from the internet every time the page loads. There are pluses and minuses to doing that. One other thing to consider is that when you develop your application, you may want to take note of what version of the library that you are currently using, because if they deprecate something in the API and you're using the latest version every single time, your application may break. So make sure that you are aware of, if you're using these libraries, that changes will happen to the API at some point. Make sure that you can kind of protect yourself against that. That's bitten me in the past with Python. I think I've mentioned that before. So JavaScript is going to be the same way. These libraries will evolve over time. Okay, so basic web application, or basic 3JS application here. Now, what the JavaScript code is going to look like is it's going to be based kind of around something that's called a scene graph. So here we're going to define a scene. We're going to actually see this with Unity later on as well. It's kind of scene-based, but this is effectively the object for what we're currently looking at. So we're going to define a scene. We're going to define our aspect ratio. I get my mouse here, and again, I'll make this a little bit easier to see next time. So it's going to be a divider between the width and the height. So what is the aspect of your monitor that you can see basically right now? Obviously, this is kind of nice if you have a square monitor versus a rectangle versus maybe something that's portrait. Then we're going to define a camera. And here it's a perspective camera. So obviously they're not using an orthographic view, it's a perspective view. Again, very easy. It is a single function call for what the camera is looking at. All right, life is good for us in Cameraland. We're going to define a renderer too. So this is going to be whether you want to use WebGL or HTML5's canvas, or whichever kind of renderer you want. Obviously, WebGL is going to take advantage of your graphics processor, but you have options basically, which is nice. Then we're going to set its size. We're going to stick that element into our DOM, which is going to be, again, let's add a canvas onto the HTML file. You don't have to define it yourself. Three.js is doing it here, and it's actually inserting it through JavaScript. Right. So that's just the setup, right? So this would be like us initiating the WebGL context, right? So we're going to get the canvas element, slap on WebGL, make sure the canvas is going to, render things properly, do all of that setup that we had to do. Here it's being taken care of in 6 lines of code, and fairly easy to read. Honestly, some of the examples that we had before, if you're not familiar with it, you haven't done it 20 times already or something like that, it's going to be hard to get into. This looks pretty straightforward to me. Then we're going to define a cube. So here we have a box geometry. So this is defining the cube. We're going to throw a material onto it. And then we're basically going to make a mesh out of, we're going to make a mesh out of this geometry and material. So we're going to take the set of vertices. So this is going to be, again, your vertex shader, basically. Then your fragment shader is going to be your material. And I'm just kind of using this as an analog. This is not the vertex shader. We're just defining an object and what's going to make it look different, right? So then we're going to have this cube object, which has these properties, and we're going to add it to our scene. And then this thing is going to be in there. This cube is going to be in our scene. And then we're also going to back the camera off a little bit in the Z direction so that we can see it a little bit better. And then last but not least, this should look more familiar to you. We're still going to have our render function. Again, this is what's going to be animated. We still have this call to request animation frame, which is going to, be kind of our forever loop. We're going to render. Every time we render, we're going to change the rotation of the cube. So we have one extra call in here for, rendering out the scene. Basically, this is going to be your pushing it to the graphics processor or pushing it out to whatever element you have. But update the X and Y values by 0.1, and then, you get something again that looks like this. Right, so again, the camera's been pulled back. We are just rotating on X and Y. So you kind of have this weird movement. We're not also moving the Z direction as well. So fairly straightforward, at least I think. Kind of another great thing about using, a library like this is that this cube element is going to be self-contained. So there's a cube.rotation property with an X property, right? There's going to be a cube dot, there's basically numerous attributes we can slap onto this object, but we don't have to go through and do, the very convoluted matrix math ourselves. We're just going to update it by 0.1. Right, so we've taken something which is very more or less complicated when we started out with WebGL, and we've condensed it into primitives. Now what you can do, if you are into graphics and you like this kind of thing, you can go into the whole argument scene of primitives versus drawing it by hand. There are tons and tons and tons of articles out there. What's better? What's not better? Primitives makes your life easier, but it's also harder on your processor. So whatever your preference is, again. My goal is to just show you some of these different technologies. All right, so that's a cube that spins. This kind of leads us to 3's idea of a scene graph. So some of the other libraries will use this idea too. This actually comes out of the modeling community more or less. Um, but basically, a scene graph is going to define what makes up our whole scene, right? So here we're going to start off with this idea of a mesh. So this is our entry point into our scene graph. What's the mesh made out of? Well, we defined a vertex. We defined a geometry. That's what Three.js created for us. But this is basically made up of a set of vertices and a set of faces. And this is going to define basically where your vertices are. Again, for us, that was basically one function call. We created that box geometry. For you guys before, that was defining the array of all of those vertices. Where is every single vertex on the cube? Is it a fan? Is it a triangle strip? Is it just a set of triangles? That's your geometry, right? So one function call. You also define a material to kind of put together onto this geometry. So is it a texture? Is it an image? Is it just a flat color? Up to you again. But basically, these get combined into this notion of a mesh. Now, we saw the mesh in Blender, right? So you were adding, when you would add a cube or a cone or whatever you were doing, the monkey head even, you'd add it as a mesh, right? So that has the geometry, has the properties of whatever material you're going to apply to it. So we got our mesh. Mesh is going to go into the scene. We can have n meshes in a scene, right? So you can have more than one cube. You can have all those particles. In the scene, we're going to have a camera. Again, self-explanatory. We need to be able to see wherever we're looking at in the scene. We also are going to have lighting in the scene as well. So is it a point light? Is it a directional light? Is it a huge sun, which just kind of illuminates nicely? Whatever light you want to define it. Again, in these libraries, it's going to be a lot easier to define a light. You hopefully got to play with the lights a little bit when you were looking at Blender. Can't remember if I made you actually do it or not, but you could change it from a point light, which just kind of emanates light from its source in all directions, or a spotlight, which you would kind of point like a camera. Okay, so this all goes into the renderer, which gets shoved to the GPU and it renders to whatever element you defined. All right, so this is the idea of a scene graph. Kind of good to understand this workflow because this is how the majority of modeling programs or graphics programs will work. You can kind of see your pipeline in here a little bit too if you look at it kind of on the side. All right, so good so far? Any questions, concerns? Okay. So then we can also define groups to add to our scene. So if we want more than one object, we could. Should probably, I guess one thing too, if any of you are Twitch experts, I'd be more than happy to mod somebody just in case if we start getting random people showing up in the stream. I know that will probably happen at some point, but I want to make sure that the quest doesn't really get disrupted or anything. So let me know if you want to be modded. With great power comes great responsibility. Anyway, so this scene, we can also define a group where we can have a set of meshes that we're going to apply to our scene. So we can kind of treat objects as a large group. So we can have, here we've got multiple meshes. We've assumed that these have been defined somewhere. We can make a mesh invisible. We can remove it. And we can have children. We can have parents. So this whole idea of the scene graph, think of it kind of like a tree. So we're going to have a scene which has a camera. So you could say like scene.camera. Obviously, I'm not saying the right parameter names, but we have a kind of a tree view here. And here we have a group of them together. And what this kind of ends up with is you can have something like this. So there's a little bit more to this code, but what the author did was he took that cube from before, he made a group of these cubes, rotated them, and that rotation kind of got percolated through the scene. And then you have this very interesting, kind of fluid, spirally set of cubes. So again, just a single cube that's been applied to a group. And if you're interested, I think the code's up there somewhere. Okay, so with our objects, whatever type of object it is, we can set its position. So here it slides in the negative 100 x direction. You can scale it. So meshes will have a scale, meshes have a position, meshes will have a rotation. So we can see this thing kind of spinning back and forth. One thing you may notice here in the bottom too is that this is in radians. So these are not degrees natively. 3 is going to use radians. If you do not like radians, you can do your lovely unit circle conversion, where if you'd rather 45 degrees instead of pi over 4, you're more than welcome to do that. There's also a handy degree to radians function, which is built into the 3 math library. So if I want 45 degrees, I can just make this extra call. Again, if you are trying to optimize your program though, this is an extra function call which might be unnecessary. So again, there's going to have to be some math being done here. Is it a trivial calculation? Absolutely. But it's one extra thing your computer has to do rather than rendering your beautiful animated character. But again, here we're just setting the Y rotation to this new value. So makes life very easy. You can also animate around the circle if you want. So we've actually seen this formula before. So if we want to do a rotation around a circle, the x value is going to be cosine of wherever we are currently at. Y is going to be sine of wherever we're at. So this t could be time, for instance. So if we're keeping track of our current time or tick or whatever you want to call it, our position x and y would just be the cosine and sine of that. Z we'd leave alone because again, we're not rotating around z. But here we have a nice little unit circle rotation. We also have a pumpkin doing the exact same thing. So basically we have a texture, a model that's been applied to our object, and the exact same formula has been applied. We don't care what the object is. We can just update its position relative to whatever we want at that current time step. All right, so we can change position, we can change scale, rotation. This is all very, very straightforward for us. You may notice, again, we are not doing matrix math. This is being handled by the library. So for the cameras, we need to find a perspective camera. So we have this kind of perspective view. We're going to set the field of view aspect to the far and the near planes. This is all defined in a single function call. You can change these parameters very easily. So if I want to change the field of view to, say, 60 from 15, it's, again, a single line here. You can change the far and near plane, so you kind of see here as I go back and forth, the clipping plane is being larger, like, embiggened. It's being made larger or smaller. So again, very, very straightforward for us. If you want to go orthographic, that's an option as well. So just make an orthographic camera instead of a perspective camera. Basically, you have options. Options are good, right? It's also more to keep in mind, but I like having these options rather than having to do the math myself. So with this camera, I kind of mentioned that Three.js has a really nice way of controlling the camera if you want. So you can actually include something called the orbit controls, where basically I'm just kind of left clicking and it's kind of rotating about this point that I've clicked on. And these are all just objects that have been added to the scene. So if I'm left clicking, I'm just kind of rotating. I'm going to middle click, it's going to zoom in and out. If I right click, it's going to pan. So we have a very, very nice view of our scene with honestly just a few lines of code. This is one of the great things about these libraries. And you can zoom in and out with scrolling the mouse wheel too. Again, this example is up on the Three.js website as well. But if I want to add orbit controls, I just define an orbit controls, and then it's going to be a part of the scene. So I've defined this control object, and every time we render out a frame, we're just going to check, hey, did the controller get updated for this? All right, has our camera position moved? 2 lines of code. something that would take you probably weeks to do by hand, or at least me weeks. You guys probably get it done in a day or so. You have options for the controls as well. So if you want pan, zoom, rotate to be enabled or disabled, if you want to set some constraints on what you can see, basically limit what the user can do with the camera, this is all available to you. But very, very handy, I think at least. All right, so now we're going to go on to geometry. So here are some of the primitives that you can use in this technology, right? So these should look familiar, especially since we just talked about Blender last week, last week. So here you've got your cube. Again, this is going to be a box geometry. Define it as we've already seen. We can also define a sphere. So life is going to be fairly straightforward. You see our nice triangles being defined here in our wireframe view. So we can have a sphere, we can have a cylinder, we can have our torus. So you can honestly model your very pretty donut right in here. Okay, so I really need to learn what all of these emotes mean. Okay, so some of the materials that we can have too. You don't necessarily have to define them by hand like you do in the pure WebGL. We can just define materials right in Three.js. So here's a basic material. Looks very flat. We don't have any real shading being applied. It just looks like a flat circle. This is still a 3D object, but there's nothing to indicate what the light is doing to the surface. So here we have a basic material. And you have a Lambert material. Kind of see the slightly dull view, but there is definitely a shading gradient happening here. Again, the light's kind of coming from the, negative 45-degree angle, 135 angle, onto the surface here. Then you have a Fong material. You had a little bit of shininess. You have a standard material with some extra shading being applied. So yeah, it's basic here. And this is standard, so a slight difference in the naming. Standard means you still get some reflection, a little bit of specular diffusion, all that. Then if you want to go the toon link angle, you can have a toon material, which kind of degrades the fidelity of the light refraction, but you get this kind of toony look, which is cool. Or a normal material where you can define kind of the various colors that you want to apply to the object. And I would leave it to you basically to look into what these parameters that go into these material calls are, because they will vary from object to object. What you can also see here too is that normals will come off of the surface. Basically, how is the material interacting with the light, with the camera, that kind of thing. So when we have flat shading, sorry, I'm skipping ahead here. So we can also define whether it's smooth or flat. So if you define flat shading to be true, you get that very, kind of polygonal look to the object. You can smooth it out as well if you'd prefer. But the difference with the normals is that when you have flat shading, basically the normal is coming off of the face. So here you kind of see two normals popping off of the rectangles, which are actually the two triangles. So the normals are coming off of that. When you turn flat shading off, okay, so here's it in more of a wireframe view. But when you turn it off, the normals are coming off the vertices, not the actual faces. So slight difference, but kind of important if we're getting down to this level. So normals coming off the face depends on if it's flat or not. We can define colors as well. So just change the color of the mesh, and then you get a different material property. You can play around with the shininess as well. So what does it look like, again, in terms of light, how much light is coming off of this object. So here it's a little bit blurry. Here it's a lot more defined. You can make it a wireframe. So if you want to test out your scene beforehand, if you want to see what your object actually looks like and how it's interacting with an object, is there any overlap happening because your collision detection is off, you can do wireframe mode if you want. Transparency, opacity is valid as well. So basically you have all these parameters which are nice and helpful for you. Now, we can also do UV mapping, which we talked about last time when we did Blender, right? So this is where we take a flat image and we're going to map it onto some surface. Now in Blender, you had a lot of control with, where the seams are going to be, how I'm going to wrap this thing onto my object. Obviously here, we're going to have to define exactly what our mesh looks like. Now, I'm not sure, honestly, in 3GS if you can actually specify where the seams are. I'm fairly certain you need to align your texture outside, like in a Photoshop type program or one of these UV mapper programs. But we can do UV mapping here, basically, which is very handy. So here we have obviously our US map, or global map of everything. Now, one of the other nice things that we haven't really talked about, but is important with UV mapping is, the specular map or the bump mapping or things of that nature. Are we going to give this thing texture? So we can apply this map in this fashion. So here we have our map being applied. We're going to create a texture loader. What UV are we going to be loading onto this thing? Obviously here you see kind of light spinning around the globe. Obviously this is the sun, and based on how close they are, maybe the reflection off the moon. Not sure what the intent is, but so we have this texture that's been loaded. So this is the normal map. You can also define a normal map. I spoke a little too soon with that one. But basically, what is the elevation of some of these objects? So, clearly the continents here have some texture to them. This texture is another type of image that's being loaded in, which is going to define, exactly what the thing should look like. So again, we're giving our object texture. So we would apply that. We can also apply a specular map, which is going to be, basically its shininess. So what's going to be reflecting light more than the others. So here the continents are going to be defined a lot darker than, say, the ocean. And when you apply them all together here, you can actually see, these mountain ranges have some definition. The oceans have less reflection than the surface does, right? So we actually see something that actually approximates a globe, which is kind of cool. But this is only achieved by having our colors, our specular map, and then our normal map, which is basically, again, how much bump mapping or like texturing are we actually applying to this thing. So if you want to look at it in terms of a material, so here they've defined it as a Phong material, given it a color, set its shininess and its specular levels, and then basically just apply these loaded maps into the material. That material gets merged in with the geometry, goes into the scene, and then you have a very, very nice kind of a programmer's pipeline in a way for that. And I should stress how easy this is compared to what we've seen before. All right, so if we're good so far, lighting, I'm not going to go into too much detail here, but you can basically define lights similar to what we saw in Blender, whether you want a directional light, so this is like a spotlight type of thing here. This has the orbit controls applied to it, so I can kind of move this thing around here. So here the position has been set at this location, and we can basically change what the light is looking at. So directional source, consider it like a camera. It is going this direction. And then we have appropriate parameters for that. And also set its level and its color. So here the color is changing to more of a greeny, teal-y type of thing. A little bit darker, you can see that its intensity level is a lot smaller, or it can be very bright and washed out. You can also set a point light where light's just kind of emanating from the source right here. Can move it around. Here we have a spotlight. Change the angle of the spotlight as well. Change its penumbra. So you can kind of see the difference there. Ambient lighting, some nice mood lighting going for our scene. You can also define 3-point lighting. So here we have 3 basically light sources being applied to our scene. we can kind of see what's going on here. Nice thing, basically, you have options again. It's going to keep coming back to we have options. Um, so again, this talk was given several years ago, so I'm going to say that this section of this presentation might be a little bit deprecated because we can load in models right into Three.js now as the GLTF files, I believe. So the common strategy before was to take whatever object that you created, again, Blender, Maya, SolidWorks, whatever tool you want, and then convert it to a JSON file. This is going to, again, specify all the parameters of your object, you know, what all the vertices are, specularity, all that kind of fun stuff. There was a tool. I think this is honestly still available, but now you can just export as a GLTF file, load that right in to Blender, or not Blender, 3 or Babylon, basically. But you know, yeah, ideally you would load models and you wouldn't define this vertex by vertex. So question for you guys. I can't remember if we've talked about this right now. Does anybody know why you always kind of see this teapot in graphics applications? So if you look at any graphics book, any graphics demo, you're going to see a teapot. Anybody know why? Will I hydrate here momentarily? Are we all still awake? It is the hello world of graphics. Yes, exactly. So it's very complicated, but simple. It's the hello world. I think these are all honestly variations of the correct answer. So if you are modeling something, so my brother, who is more into the Twitch scene than I am, told me that my first live stream had to be poggers. So hopefully we're delivering on that. And I had to look that up on Urban Dictionary because I'm elderly. But yeah, this is honestly a very complicated shape to model. So you have this kind of deformed extruded cylinder here. We have a hollowed out shape. You have this handle attached on. Looking at it, it's a very simple object, but for graphics, it's honestly very tricky to render because you have this through hole going through here. You know, if this lid wasn't on, you would have a rim that it has to sit on. There's basically just a lot to it. And honestly, if you look at it from the top view, this isn't just a straight tube that's been extruded. It's, you know, kind of going in and out here. So the hello world is a great way to describe this, but it is a complicated object too for graphics. For you guys, you know, not. But again, if you want to load this in more in the old-fashioned style, you could load it in as a JSON file. We can load it in as a GLTF file now, but the same concept would apply. You would load it in and add it to your scene, applying whatever textures and meshes that you want to. So then we're actually getting kind of towards the end of the set of slides here. Here's 3 teapots that have been applied to a scene. Now, these are all going to be copies of each other. Let me get the mouse out of the way. 3 different textures have been applied to this object. There are different refractions that you can see happening here. Obviously, the one in the middle, very metally. Here we have kind of a glassy, distorting the scene look, and then a very flat, still glossy texture over here. Actually, this is interesting. So I didn't notice that, but if you look through the spigots, it's like there's just a hole straight through. So there's actually kind of a problem, unless it's reflecting from the inside. But you can see right there. Anyway, here we have a scene. So this is actually a really interesting example, I think. So you have this lovely bridge and water, and you have these 3 pots floating. This is in something called a skybox. Anybody know what that is? I move forward here. Excuse me. So I've actually started, I moved the slides ahead one. We're starting to see a wireframe around the outside. But what this is, we're inside of a cube. All right, so we're inside of an actual box. Yeah, so here the world is just a cube, right? So there's a texture being applied to every single face of the cube, where if we're at it on the inside, our teapots, the teapots might be normal sized, our skybox is huge, and that texture has been applied to it. So honestly, kind of a very cool thing. If you zoom in, it looks like we're in this world. Obviously, the waves aren't moving. There's no motion to the texture. But, this is the idea of a skybox. So again, we're going to have to map this to a cube to make it look normal. If we look at it from this side, it's very, very distorted, but, the notions that we have here still apply. Somehow I lost my place in the slides. Yes. All right, and then I believe last but not least, interacting with the scene. So obviously we had the orbit control, so we're interacting with the camera. Now we have interacting with our scene. So this is something called picking. We talked about this at the very beginning of class. This is a non-trivial activity in graphics, right? So I'm just kind of moving my mouse around. I'm not clicking or anything, but you see these various cubes highlighting. Now, the orbit controller has been locked, so the camera is just slowly rotating. I can't move it. But what's happening here is something that we probably, if we had stayed with the book when we started talking about raycasting, we would do something like this. But we have this notion of picking. So we have these 3D objects. It's in a 3D space. Your mouse cursor is in a 2D plane. How do you map to the objects that you're going to select? Well, one way to do that is with a raycast. So basically a ray is being sent out from the tip of the mouse to the camera, or so to, basically your far plane. And then whatever that ray interacts with will be selected. So we're gonna have to do some math every time we move our cursor to, or every time something moves basically, what is interacting with this ray, right? So we're gonna have to do basically a calculation from a vector to everything in our scene. So this is basically raycasting. So here we have our camera, right? So our camera, or our person's here looking at this plane. This is our browser window. And then here you have your far plane back here. What are we touching? Again, this is a very non-trivial application for any kind of graphics. So how this works in WebGL, in 3JS, basically you're going to get your mouse X and your mouse Y, and we're going to normalize it. So kind of like how you did before when you were picking objects in the 2D plane. But instead of manually doing collision detection, you're going to do a raycaster. Now, 3JS makes this easy. Let's define a raycaster object, link it up to where the camera and the mouse are. So again, here we're passing in our mouse coordinates, camera coordinates, and then we get a list of intersected objects. So pass in all of the scene's children, so basically all of the meshes that you defined, all of the objects that you put in there. These are going to be passed in as basically a list of objects. What is the raycaster hitting? Right, this is going to come out as some intersected object, or a list of intersected objects, basically. And then just based on what's intersected, change the texture to highlighted. Right, so we saw before you can update the texture and update the specular levels, update the color. So what we're seeing here, if we go back a little bit, this presentation's starting to kill my computer because it's a lot of processor work here. But again, we're just changing all these textures to red. So that would be changing the intersected object. Okay, then last but not least, so the guy who gave this presentation had this little end demo, but this is really cool. Probably going to be a lot of dropped frames on your end, but we see some particles kind of zipping around the background. We have this pyramid with these speakers. And orbit controls. So pretty neat stuff, honestly. I want to say his code is up on GitHub too, or at least on his website somewhere for this, but I think it's really neat, honestly. So that's kind of Three.js in a nutshell. Again, if you guys end up becoming presenters or teachers where you have to deliver online content, I really like that whole web-based slide deck thing. I may figure that out one of these days. But I would highly recommend checking it out. So that is your intro to Three.js. Now, some other things you can do. This is actually a colleague of mine from several years ago. He came up with this research tool for using Three.js and Fuzzy.js to basically create robotics, creatures, something of that nature. So I've got the link up in the slides, but basically there's some very complicated algorithms going on in the background to evolve this shape to make it walk. So can we figure out how robots walk, or how to make a robot walk by, playing with its joints, playing with motors and things of that nature. So here we have this object. It's a bunch of, very simple cubes linked together. You can kind of see how far they're moving. And every time that the algorithm moves forward, the creature moves a little bit better. So it gets a little bit smarter. But from your perspective as graphics programmers, we have a scene. We have a bunch of objects. We're creating new, looks like little spheres to demonstrate how far it's moved. And you can do really neat things. It doesn't just have to be a game or a fluid simulation. It can be, very complicated research topics. And I know that I don't have the link to the website on here, but you can actually play around with some of the algorithm parameters to see these shapes change. All right, any questions on 3? Otherwise, we're going to move on to Babylon and kind of zip through it. So Babylon and Three.js of the emotes, they do effectively the same thing. So they're WebGL, 3D, JavaScript engines, basically. Whether you pick Babylon or 3, we'll talk about momentarily. I've got a link to a Babylon demo up on my Google Cloud page. But it's just loading a ball, so this is their hello world. Okay. So basically I'm just kind of zooming, rotating, panning, all of your usual things you can do. So the template's up there. It's also on their website. So I'm pretty sure we've actually looked at this one before. Maybe not. It must have been the Three.js we looked at. But there are a lot of examples up on Babylon for doing various things. So here they actually are going to walk you through how to add animation, how to do bone animation, instancing. So if I want to create an object and then create multiple instances of the same thing, you can get this lovely Schwarzenegger, Quake 4, Droid Army type of looking thing. But these are all just clones of a single object. All right, so Babylon looks very, very similar to 3 in terms of loading up the code. So here I have some, honestly, this is an example of pointing towards internet-based library hosts. So here Babylon's actually hosted on their website. So we've got those guys loaded in. There's also this jQuery pep thing library that's being loaded. This is basically handling touch events. It makes it a little bit easier. But here we actually have the canvas being defined. So Babylon, whatever object you want to render to, it's going to be up to you to define. So here we have our canvas. Our canvas has some, well, we're basically going to use the canvas. And then we have our JavaScript code down below. You can obviously put it wherever you want, but we need to get the canvas, and sorry, the text isn't all in one line here. We're going to get the canvas and then we'll interact with it. Whereas before, like 3JS would automatically create it for you. And here you're going to create a new Babylon engine. So instead of calling like 3 dot box geometry, we'd call Babylon dot something. But it's going to be in reference to this 3D engine. And this doesn't look nearly as nice as what I had before. But we would create a scene, we would create a camera, we can add lights. Again, it's going to be a translation from 3 to whatever the Babylon API is looking for, but we have a very similar concept. All right, so add a camera, it's 2 lines of code. Add a light, it's 1 line of code. It's not, 30 lines of code defining all the vertices and all of that kind of fun stuff. If I want to add a sphere, it looks a little bit different. Here I'm going to create a sphere. I might give it a diameter. So basically I would pass in parameters in this kind of dictionary style lookup here. So idea is that the API is a little bit different, but the concept is the same. And here we don't necessarily have called a request animation frame. We're going to allow the engine to handle that for us. So basically, instead of that JavaScript function, which gets called endlessly, the engine has its own function for calling itself endlessly. Right, so again, I'm zipping through it intentionally because the concepts are all the same. The API is different. The function calls are all completely different. But the idea of a scene graph, the idea of abstracting out calls to make your life easier is a part of it. All right, so differences here. I spent a lot of time looking to see what the differences are and why you'd pick one over the other. So if you want a 3D, WebGL/graphics application, pick one. They're both fine, right? There's nothing wrong with either of them. In 2019, 2020, a lot of the articles tend to recommend Babylon more. And the reason is that it seems to be a little bit more complete. So Babylon by itself is a cohesive engine with everything baked into it, right? It tends to be better documented too. And now better documentation is a good thing, but it's very arguable to me, honestly, because 3JS has been around for a lot longer. Babylon is a relatively new framework. There are a ton of 3JS tutorials and applications out there as examples. But Babylon, when bugs get logged, it tends to be fixed very quick, and some of the big industry graphics partners that are out there tend to be throwing their weight behind Babylon, which is interesting to me. So pick whichever one you like. They're both fine. Babylon seems to be recommended more, but I can't conclusively say why one's better than the other, like performance-wise or something like that. So that was all the 3D stuff. Now we're going to talk about the 2D stuff, and we have about 20 minutes left, so my guess is we're not going to get to the actual in-class thing where I dip out early. Phaser is kind of cool. So I like Phaser for 2D web applications. It is very, very popular, again, with game developers who are doing web-based things. And if you're wondering if web-based games are worthwhile to make or web-based 2D applications, there are exporters to package up, say, Phaser applications and sell them on the Nintendo Marketplace or on the Steam store. You can take these web applications and actually make them into sellable entities, which I think is really interesting. So it's definitely a viable way if you like, JavaScript-based programming, you want to get a wider audience, that kind of thing. Now with Phaser, I will have a bit of a caveat here. There are 2 versions that are out there right now. There's Phaser 3 and Phaser 2. The API has changed drastically between the 2 of them. So if you're following any kind of a tutorial, make sure that you are following the tutorial for the version that you want. And I will say that not all tutorials have an analog between 2 and 3. So if you have used Phaser in the past, stick with what you know. Otherwise, the newer version obviously is preferable because that's where they're going from here. I've got a link here as well for getting started with it. With Phaser, you also have the XSS issue, so the cross-site scripting problem where you actually have to run a web server behind the scenes. So use your Google Cloud platform or your local web server, but basically you have to run this, otherwise the browser is going to complain to you. Not necessarily the case with 3 or Babylon. And yeah, here's a link to the library itself too. So Phaser, this is a 2D library again. It's slightly different in its concept. So basically here we're going to create 3 or 4 functions which are going to define our basic application. All right, and these are going to be defined via some configuration. Now, a little bit more straightforward here. So we're going to define the type of application. If you pick auto, it's going to try to find your WebGL canvas. You can also have it render as pure HTML5 or pure JavaScript. Obviously, we want our GPU to do the heavy lifting here. We can also define the width and the height of our scene. And then we're going to have a few functions here as well. So preload is basically going to load all your textures in. Create will define the basics of your scene, and then update's going to be our kind of our forever loop that we have. So basically all of our scene essentials will be defined in this configuration. There can be a lot more in here too. So we're going to kind of run through one of the Phaser tutorial demo kinds of things. So there's a 10-part demo game which will show different aspects of creating an application as you go. It's basically adding on parts. I'm just going to show 2 of those parts instead of all 10. But yeah, it's kind of helpful to see how these things work. So here's preload. Here we're actually loading in our images. So basically in the 2D space, we're not necessarily going to be texturing objects. We're going to be loading in sprites. So sprites are going to be, they're either going to be static or animated images, but basically it's going to be some objects that you're going to apply, your transforms to, or your collisions to. Right, so here we have a sky, the ground, a star, and a bomb being loaded in. So these are just static PNG images. We can also have this notion of a sprite sheet. Have any of you ever seen a sprite sheet before? I've lost a viewer. Oh no, what are my analytics going to do? Oh, cool. Awesome. So sprite sheets are actually quite interesting. Basically, you're going to define all of your animations inside of an image file. So if you guys have seen them, this should look very familiar. If you have not seen them, this is going to be new to you. But basically, you have all the different frames of your object that you want to animate. And you would basically define how wide each of these are and what you're going to transition to next. So here you have Mario, obviously running, jumping in his different directions. And this purple guy at the bottom is basically a walk animation for the tutorial guy. So you define its width, you define its height. You actually see it here. So how wide is the frame? How high is it? And it's just a single file. So the benefits to doing it this way is that I'm loading in one image instead of, here we've got 9 states for this character. I don't have 9 separate files. Obviously Mario up here, you've got his sprite sheet. This will save you a lot of effort in terms of file size, basically. And what this is going to get to is something that looks like this as soon as it loads. So here we have some stars loading in. We see the guy moving around as I arrow over. I can jump. I'm not touching it, so he's just looking at me, so my default state is looking. But based on which key I'm pressing, it's going to key in the various, animation frames. And the Phaser framework is going to handle basically where we are in the animation loop. So, draw this one, then draw this one, then draw this one, then go back to the other one based on what we are doing. So we would basically be loading in the sprite sheet. And what we see here too is that the background is just black. Oftentimes you'd use a magic color like that hot pink that I use, that FF00FF, basically something that you can color key out, so make a transparent color. Not going to get into that too much, but you basically want to differentiate your object from a background so that you have a nice, kind of a nicely bordered entity. Okay, so the first part of the demo is just loading in images. So here is our create function. So we're going to add an image, add its size, and then here would be the demo, basically. Part 3, thought it was, must be off by 1. Let's take a quick look at the source here. So here we're going to load in the library. So we're going to pull it in from this jsdeliver.net. So basically this is an NPM library where phaser is being held. Our config is going to define a basic scene. We're actually going to load in all of our assets even though they're not being used. And create is going to add the sky. All right, so if we look at our sky, so this background is actually kind of an image here that's being loaded in. Nothing's happening. There's no update happening. So basically we have a very blank frame here. All right, so if you want to load objects in, there would be your example. And now if we want to add in some platforms, we can actually apply physics to them. So here in our sky or our create function, so we're loading in our sky, and then we're going to add a group of these platforms. The platforms are just rectangles, basically with this ground tag being applied to it. We're going to create these platforms at various locations, and then we're going to set some physics here as well. So we're going to apply arcade physics, which is going to give it a more, cartoony feel. You can apply more realistic physics too. You can set the gravity of your objects, of all of the things that can move around, whether they're rigid-bodied, fixed, or whether they are, moving around and they're going to have gravity applied to that. We can set that in here again. This is going in the config object here. So we have this part 4, which I'll pop up here. And now we have these 3 objects, right? So again, there's no character in here yet. We're not doing anything, but it's the wrong keystroke. I don't want the console. I want the code. So again, this is the exact same code that I just showed in the slide, but we're still loading in the objects, but now we have this platform which we've created, and then we've made duplicates of it. So here we have our 3 platforms. All right, and then lastly, we have the fall game. So this is what I showed earlier, where we have our, oh, it's zoomed. That's why I can't see the 4th one. So I knew there was a 4th platform. That was the ground. I, for some reason, was zoomed in too much. But you see these stars are kind of bouncing. Again, they have a very arcadey feel. My guy is moving around. I hit up to jump, and he's got this very floaty gravity applied. So we're on some other planet, right? But you can play with these values to make it more real or less real, whatever you prefer. And then once you beat it, you get actually, so I got hit by this rock. If you keep playing it and collecting stars, you can get more and more rocks going. And it's a very, very simple game, but very easy to get up and running with a very simple 2D sprite sheet physics-based platformer. Right, so I think I threw out every single popular Steam tag right there. But our scene's configured very simply, right? So gravity, arcade physics, things that you would have to consider kind of difficult to program by hand if you didn't want to use a library like this. So we're going to load in our assets. So we're loading in these PNGs in a sprite sheet. And zoom in a wee bit. So we define our platforms. We define our player. It's going to be added to our physics group. We can set this person's bounciness level. So what you might have noticed is that, let me refresh here. When this guy jumps, kind of bounces. Doink. So that 0.2 is his bounce level, basically when I interact with a rigid body. Rather than having to worry about doing collision detection on the edge, I can just say collide with the world boundary. And if it's false, I could, do whatever I wanted, maybe make like a Zelda scroller where I go off the screen or something like that. And then, I kind of glossed over the animation, but we would actually define an animation set of functions here where basically if the left key was pressed, use these, 4 frames to start at the starting location and at the third index. That'd be the third index of your sprite sheet. And then you can define things like the frame rate, how quickly that frame changes, what happens when I turn around, what happens when I go the other direction, based on, whatever key you press, you would define an animation based around that. Right? So then we also have our stars that are in there. So basically these are just extra objects which change their Y direction. They have a bounciness level again. And here actually they will vary the bounce level. Again, I know I'm glossing over a lot of this, but basically this library will make it very easy to do, any kind of a 2D application. And this platformer is kind of a nice segue into it. Now, if you wanted to get a little bit deeper into Phaser, oops, I can go to the wrong website. Yeah, so desktop and mobile HTML5 game framework. But there's a ton of examples out there for this thing. So I just picked a very trivial platformer. But if you want to do, kind of a nice little isometric or perspective game here, here's Arkanoid. Lots of plugins that you can apply to. So here's the tutorial I went through. Yeah, tons of stuff you can do with this, and it's fairly, once you get into it, it's actually not that bad. All right, so questions from today at all? So we're gonna end a little bit early, but hopefully this stuff made sense. If you want to go, again, for your term project, at least in the class, I don't care if you use a library. If it's going to make your project that much better, definitely go for it. If what you're currently working on doesn't need the library, again, stick with what you prefer. I like libraries for this kind of application because it takes all the heavy lifting off of you, but it's good to know, the basics of WebGL too. So for today then, if you have any comments about how this worked, if this type of setup is going to work for class for you guys, I think this worked well from my end. Hopefully the stream wasn't too glitchy for everybody or anything like that. Again, we don't have a whole lot of interaction. We don't normally have a lot of interaction in the class anyway. You guys will kind of chime in when you want, and we'll do in-class stuff as you go, but more or less you're all fairly self-sufficient, so I'm not too worried about you. But if you have any questions about the content, feel free to dip over to the Discord channel and ask questions there. But what I'd like you to do, I've set the deadline for Thursday for this because, I would normally have you do this by tonight, as it should be fairly trivial. For in-class things, I'll give you a couple extra days. If that's not enough time, with this way of delivering content, let me know, and I can be very flexible for this. But just pick one of these frameworks. Yeah, I don't care which one. Pixie, Phaser, Babylon, or 3, or if there's another one out there that you want to explore, feel free to do that. And just implement a demo project. So again, you don't have to do in-depth development, but get like their Hello World running or get one of their cool demos running. Then just throw it up on your Google Cloud page, send me the link through Moodle, and that will be pretty much that. So, see, I'm gonna need some awesome outro music. Like, comment, subscribe, ding the bell, etc., etc. Had to do that at least once to sound really elderly on Twitch. So this has been recorded, and I will throw it up on YouTube. I will put it up, the link to the YouTube video up on Moodle when it's done, encoding and all that fun stuff. So anyway, thank you all for your patience and for, looks like pretty much everybody participated. So that was honestly pretty cool. I like this. If, again, any comments, anything like that, feel free to, I've got a thing for this. There we go. And also, I guess the face cam is distracting too. I can get rid of that. I left it on just to see how it would go. Um, but again, anything you guys want, let me know. Anyway, talk to you all Thursday. Bye bye.